Hey guys, this is the first set of notes for Unit 5. Today we're talking about bonding basics. So we have 2 more units to complete this semester. First, you need to know about the octet rule. This says that atoms can gain, lose, or share electrons to achieve a full and stable outer energy level. So like argon, that's pictured here in the corner. Argon is in group 8, so it has 8 valence electrons. So it is already stable. A full energy level equals 8 valence electrons. All atoms want to have a full outer shell. Hydrogen and helium, instead of having 8 like all the other elements, they only need to have 2 valence electrons. All other elements are full once they have the 8. Noble gases are already stable because they're in group 8, so they don't need to gain any more electrons to become stable. All other elements are going to be more stable in compounds. So when elements form compounds, they become stable because they're either sharing electrons or they might be gaining or losing to fulfill that octet rule. So why do atoms bond? Atoms are going to bond when a compound is more stable than the separate elements. The elements no longer have the same properties as they did before forming a compound. So if you think about water, H2O, hydrogen and oxygen are usually found in the gas form, but when they bond and combine, generally water is going to be a liquid. So they have completely different properties from when they're elements to when they combine to form a compound. There's 3 different types of bonds that you need to know. The first one is called ionic. This is between a metal and a nonmetal. The second one is covalent, which is between 2 nonmetals. And lastly, metallic is between 2 metals. So that's when your periodic table that you colored will come in really handy because everything should be color-coded already. So first we have ionic bonds. In an ionic bond, it's between a metal and a nonmetal. Electrons are going to be transferred. So generally, metals have the fewer amount of valence electrons. They're going to give their electrons up so that they can become stable. Nonmetals on the right side of the periodic table are really close to having 8 valence electrons, so they're going to gain electrons. There's going to be a high electronegativity difference. So when we're writing chemical formulas, there's a few things that you need to do. This is called the swap and drop rule. So first you need to know what the charges are of your elements. Those should be written on your periodic table already. So for aluminum, it has a +3 charge because it's in group 3. Oxygen has a -2 charge because it's in group 6. So that's where that +3 and that -2 comes from. If you don't have that written on your periodic table, just go back and look at my picture on the class website. So the first step is to drop those signs. The signs is the plus and the minus. So now I just have Al3 and O2. The second step is to just swap the numbers. So where aluminum originally had 3, we're giving that 3 to the oxygen. Where oxygen originally had 2, we're giving that 2 to the aluminum. We're just switching numbers. So step 3 is to drop the superscripts down to subscripts. You can just write to drop the numbers down. So now my complete chemical formula would be Al2O3. You have this chart in your notes. This is just some of the elements that we're going to be using a lot and a few that are on your notes today. Oh, one thing I did want to mention on that chart, on that last slide, it won't let me go back, but on that chart, on the very right side, it says oxidation number. Oxidation number is just the charge. So it could say charge or it could say oxidation. So my first example here is sodium and chlorine. I'm going to go to my notes so I can write this out for you. Okay, so I have sodium. Oh man, let's try that again. Sodium is Na, and then it was chlorine. So the first thing I want to do is figure out my charges. Sodium's in group 1, so it's a +1 charge. Chlorine's in group 7, that's a -1 charge. If I swap and drop, I end up getting Na1Cl1, and you don't have to write the ones, you can just write it NaCl. If you want to write the ones, you can for now, but on the test it probably will not have that. So that's the first step. Next, we can decide if this is ionic or covalent. So sodium's a metal, chlorine's a non-metal, so that makes this an ionic bond. So the next thing that you're gonna have to do is draw out the Lewis dot or the electron dot diagrams. We've done this before. This is where you just show me how many valence electrons it has. So there's sodium, it has 1. Chlorine has 7 because it's in group 7. So it looks like that. Now, because this is an ionic, that means that electrons are being transferred. So to show that, I'm going to circle my electron and just show that it's going to go to chlorine. So sodium's going to give up its electron to become stable. Chlorine wants to gain an electron to become stable. So these can form a bond. Okay. My next example is beryllium and fluorine. So beryllium, fluorine. Beryllium is +2. Fluorine is -1. So if I swap and drop my charges, I would just get BeF2. Again, this is a metal. This is a non-metal. So it's going to be an ionic bond. Again, electrons will be transferred. So if I'm drawing that out, I have Be, which has 2. I'm going to draw them down here just to make it easier. I have a fluorine, 1, 2, 3, 4, 5, 6, 7. So beryllium really wants to give up its electron, so it's going to give it to this fluorine. However, I still have one more electron over here. If you notice back on our formula, it says that I have 2 fluorines, so I need to add my other fluorine. So I have 1, 2, 3, 4, 5, 6, 7. And again, this electron is going to go towards fluorine. So now beryllium's happy because it's stable. Fluorine's happy because it's stable. Next, we have covalent bonds. These are going to be between a nonmetal and a nonmetal. Neither element's going to give up its electrons because they're all pretty close to having a full outer shell. So they just share electrons. Each element's going to donate the same number of electrons to be shared. The number of electrons that are shared determines the type of bond it is. So it is a covalent bond, but within that you can have a few different things happen. You can have a single bond. That's where you're just going to share 2 electrons. You can have a double bond, which means you have 4 total electrons, so 2 electrons in each pair. Or you can have a triple bond, 6 total electrons, so that would mean you have 3 pairs with 2 electrons in each pair. The electrons that an atom has available to share are the electrons that are not already paired up. So when you're drawing your Lewis dot diagram, any of the electrons that don't have a pair, that's the one that's going to be shared. Some characteristics of these, they're going to form molecules usually. They are held together by covalent bonds. They have low melting points. That means they're pretty easy to break apart. They're soft. They could be a solid, liquid, or a gas. Generally, they're not going to dissolve very well in water. If they do dissolve in water, they're not going to be electrolytes. So that means they won't conduct electricity if they are dissolved in water. So here's our first example. We have hydrogen plus hydrogen. I'm going to go back to my notes over here. Okay, hydrogen plus hydrogen. So just as a helpful tip, anytime you have the exact same element bonded to each other, you don't really need to do the charges and the whole swap and drop thing. So in this case, I don't need my charges because it's a hydrogen bonded to a hydrogen. It's the exact same element. So I'm just gonna say how many hydrogens I had. So I have 1, 2. So I'm just gonna say H2. That's it. So hydrogen is a nonmetal, so it's a nonmetal plus a nonmetal, which makes it covalent. So when I draw that, I have a hydrogen here with 1 valence electron. I have a hydrogen here with 1 valence electron. And since it's covalent, they're sharing electrons. So to draw that, we're gonna draw a circle. So now those 2 electrons are shared between both hydrogen atoms. Hydrogen now has 2 valence electrons for each one, so it's happy and it's stable. Next we have hydrogen plus oxygen. Okay, so again, hydrogen has +1, oxygen has -2. So in the last example, it was the exact same element bonding together, so I just counted how many I had, which is where that 2 came from. In this one, these are 2 different elements, so I need to do my charges and swap and drop. So it would be H2O is my formula. Okay, after that I can draw what that looks like. I have an oxygen, I have a hydrogen, I have another hydrogen. So I have 1, 2, 3, 4, 5, 6. I have 1 on each of these. Again, since this is covalent, they're gonna be shared between them. So now hydrogens both have 2 valence electrons, and oxygen now has 1, 2, 3, 4, 5, 6, 7, 8. So everything is stable and happy. And there is a video on the class website that you can go watch to help further what you learned today in these notes. Lastly, we need to talk about metallic bonds. These are a lot different from covalent and ionic. Instead of just a bond between 2 atoms and the electrons either being shared or transferred, this one is going to be many atoms of a metal, so like gold, silver, zinc, things like that. And there's a sharing of electrons between many atoms. That sharing of electrons is called a sea of electrons. That's going to be really important to know. So take a look at your desk and see if you can find a small piece of metal like a paperclip or a staple. All of the atoms in that small piece of metal are sharing a big pool of valence electrons. This is known as a sea of electrons. This is kind of like a free-for-all in that any valence electron can move to any atom within the metal. So metallic bonds have tons of valence electrons that are just shared between all of the atoms in that.